What's up everyone? This is Ayush, and in this tutorial we're going to be looking at computer networks and security assignment in which you have to configure the OSPF routing. Well, this is like the complete problem statement. So basically you can use RIP, OSPF or BGP. I'll probably be covering all of these protocols one by one, but I'll first be showing you OSPF just because OSPF is a bit more, I would say, complex as compared to RIP. Brief overview about OSPF. It's basically a link state routing protocol. Now, there are two types of routing protocols, right? There's link state and there's distance vector routing. So this is basically a link state routing is what you need to know. These are some characteristics of it. It has like a hierarchical design. It's fast convergence and cost-based routing is what makes it kind of very popular in today's applications. Most of your enterprise network are probably run on OSPF routing. There's this difference which is asked in the examination on OSPF border gateway protocol and RIP, which is routing information protocol. So you can probably just pause the video and read it. This is not very something very different. And this diagram is what we will be configuring today in our tutorial. Well, this is something which I got from Wikipedia, but we'll be doing something a bit better than this. Okay, so this is our Cisco Packet Tracer. I've saved this file just in case. Now what I'm going to do in the beginning, right off the bat is just take a router from this. You can probably find the router over here in routers. Just take three routers. I mean, in OSPF, the reason why we are taking three routers in the first place is like दो router लेके sense नहीं बनता ना, because if you just take two routers, then going to be only one path between those two. So there's no use of any shortest path algorithm. Also, one more thing, this OSPF uses the Dijkstra's algorithm to kind of find out the shortest path. You might have probably learned about Dijkstra's in like data structures. So what basically happens is that each of the routers will periodically send like a map of its surrounding topology to all other routers. So this will send it to router 0, router 1 when they are connected. And that's how they kind of map out the entire thing and avoid loops. Before we start with the wiring though, I'll just take a switch and put it in every network. So now we have switches in every network. We'll add end devices. Let's put a laptop in this network. Let's put another laptop here. We can put a desktop here as well. I think that's pretty much it. Now we'll go to wiring. So you can probably use this option as well, automatically choose connection type. But I personally prefer going with specific options. So this is copper straight through. The reason for choosing this is you get to know which cable is applicable for which specific port. So yeah, uh, I'm going to select this port and I'll put this in fast Ethernet. Right, so I have connected all of them. I have not configured anything yet. Before we get to configuring though, what I want to do is I want to connect all of these routers together. So for that, I think we'll be requiring serial cables, although it can be done using crossovers as well. But the problem over here is we don't seem to have any serial ports for this particular OSPF algorithm. So what we'll have to do is add serial ports manually in this. So you can see in these modules, first of all, you switch off the router. Then you look for manuals with serial ports. So the HWIC2T is a 2-port serial high-speed WAN interface card. So this is what we are supposed to install. So you drag and drop it over here, and we turn the thing on again. Now you have to do the same thing for this. This is like pretty repetitive. Just make sure to like close the routers and like restart them afterwards. Yeah. So that's pretty much it. This was like quick. It doesn't really require that much time. Now we have like serial ports with us. So we'll just connect this around quickly. Serial 1 to serial 1, and then this to this. Right, so this is like now connected. Now what I'm going to do, just for my sanity and ease of configuring, I'll just write down my IP addresses for all of the networks. Alright, so now we've named, I mean not named, but we have like decided IP addresses for all our networks. So that is cool because we'll require this frequently while actually configuring. Also, one more thing, this like generally these networks are like really far apart. So just to kind of give an example over here, this over here, this network is in Pune. Maybe this network is in say London, and this network is in Tokyo, Japan, right? And I mean this is how usually it happens as far as I'm aware of. These are all the networks. We have to configure them one by one. So first of all, I'll start with the end device on our first network. So I'll just go to PT laptop. Over here in configurations, we go to fast Ethernet. We put down the IP address. We have to enter 192.168.1.2, right? And over here I have entered 192.168.1. Also, this router is going to be the default gateway for this end device, or well, the gateway in this case, because there's like only one router, so the default gateway is going to be the gateway. Right, so what the gateway is going to basically do is when traffic comes to this router, it's going to be like, you can think about it like a door for a classroom or a room. Everything that has to enter and exit from that room has to go through the gateway. So like matlab gateway configure karna is very important. If you don't do it, then like packets won't go through that gateway because gateway को पता नहीं like end laptop को पता नहीं कि उसका gateway क्या है. Anyways, enough yapping. Let's configure the rest of these. I forgot which port this was on, so this is on fast Ethernet 0, so I'm going to configure this. I'll put the gateway also, so 192.168.2. I'll say 1 over here, then here 192.168.2.2. See how it doesn't give me an error now. Hold up. Yeah, it doesn't really give me an error over here now because the addresses are not overlapping with the network one. Again, let's check the port. It's 00. So we'll go over here, turn it on, 192.168.2.1, the default subnet mask. Then again over here, we'll configure this one on 192.168.3.1. As a matter of fact, you can use any IP address over here, anyone which you want, as long as it's obviously valid IP address. I mean, yeah, if you don't use a valid IP address, you'll get an error. But it's not hard and fast key. I'm using this IP address, so you have to use the same. I'm just using this because I'm familiar with these types of IP addresses. So this is 3.2 for the PC, and we'll configure the gateway over here. So 192.168.3.1. Right, so now we have configured all the end devices and their ports with the routers. If you want, you can go ahead and check this with kind of this simple packet thing. So this is successful. You can go ahead and do this for each and every one of your individual connections in case you have any questions regarding that. I'm not going to do it for every connection. This is where we start configuring the serial ports. So the serial ports have a clock rate and have an IP address, right? So for this particular line, it's serial port 0, 0 on both sides. So I'm just going to go over here, first of all, I'll put the IP address, so 20.20.0.1 and turn it on. So the clock rate over here is 200,000. You can probably leave it at 200,000. It really doesn't make a difference.
You are fake news.
But do make sure that the clock rate is equal or like the same for every router, or it may cause an issue. I haven't really experimented with this, but what happens is this is like the clock which controls your signals. So it's because it's a serial line. So signals have to be like uh, efficiently managed. I be yapping a lot these days, guys. They call me the yapster of CNS. Not really. Just 25.25.0.1. Okay, just make sure select that again in case. Also, if you don't remember the port, you can just hover over the wire and you can see which port you connected your wire to. I think that's really nifty in cases where you forget. Okay, wait, I messed up. Now it's supposed to be 2. Yeah, and we yeah, this one. I, it's 200,000. Oh, it's 2 million. Yeah, the clock rate is 2 million, not 200,000. Anyways, doesn't really matter. We're not concerned at all about the clock rate right now. So turn this on. This is 30.30.0.1. Also look at the subnet mask over here. It is different from the one used over here. That is because this was a class C IP address and this is like a class A IP address. So the bits, the host bits and the network bits are different over here. Just a thing you can notice if you want to, or don't notice it, who cares. So we've configured all our routers. I'm just going to double check all the configurations in case, yeah, exactly because of this I wanted to double check, because sometimes it will just automatically decide that अभी मैं अपना clock rate भूल जाऊंगा and like some oddity will occur. We wanted to go with like the using the shortest path, not using like the longest path. So for that we'll have to configure OSPF on each of the routers. So over here you can see it's config if. I'll exit this. Actually I'll exit the entire system only, because sometimes what will happen is you will get like message directly. So what you have to do when it's just the router, you need to enable it, configure terminal, and then when you get this config in brackets over here, you can go for router OSPF and process number 1 Then you get this config router, and now we put in our network commands, like the network which we want to configure. So the syntax for this given in the manual for um, Cisco Packet Tracer is basically you first enter network followed by the IP address of your network. So for our first one, it's 192.168.1.0. Then followed by the complement of the subnet mask, which is 0.0.0.255, and this area 0. This is supposed to be a card. Try to remember it. I'll try to explain this in a future video. Then we'll go for the next IP address 20. So just like that, you can configure all your networks and then exit. No need to exit like the entire thing. Just remember to save this configuration. So you'll get like the sys.config building configuration OK, and then it'll save it. If you don't save it as like immediately, जैसे you close this router 0 का thing, your hard work will be wasted. So please don't do that. Can do router OSPF 1. In case you don't have this, I have already shown you like the steps of how to get to the config braces. So you can just use that. Now we have router OSPF 1. Then we'll go for the network commands again. So network with the IP address, so 192.168.168.2.0 with the subnet mask, the complement of the subnet mask, that is. So our subnet mask is 255.255.255.0. So just uska ulta area 0. Now we'll have to do 20.0.0. So I've just done that. The subnet mask for this is different. So again, okay, this is some sort of backup process or something. But you can see over here, OSPF 5 ADCHG and process 1. This is process 1 because we did router OSPF 1, so that was like the process ID. If this happens with you, just run all of these commands again to make sure that like nothing got lost or something. This is done. What I did basically was after this message automatically popped up, I just like fired all these commands again. You can easily do that using the upper arrow key just to make sure that everything is configured properly. Then I'll save this, close this, and for this the same thing again. We'll do router OSPF 1, then the IP addresses. So London is 3.0. So you'll do network 192.168.3.0 with the complement as 0.0.0.255, the subnet mask, and area 0. Then we'll configure our class A IP addresses. This one is going to be 25.25, and we'll do the 31. So okay, just very interrupting. I'm just going to run all of these commands again to make sure that nothing gets missed. You can save this, it's successfully saved. And yeah, like your this OSPF network is basically configured right now. We can probably test this by delivering a packet. Okay, it failed. So remember how we set the clock rates to 2 million? So apparently you're not supposed to do that because this hardware has some limitations. Um, I think if you go with the generic routers, this is not the issue. Router PT or router PTMT. This is like a specific version of the router. So this has some hardware limitations where it cannot do 2 million clock cycles per second or something. Again, very understandable, guys. 2 million clock cycles per second is a lot. So again, 200, we've configured it at 25,000. You can just scroll up and down and it will like set itself. So yeah, we've set it at 25,000 and now it is working. So if I send a packet from here to here, it will work. And yeah, we successfully configured an OSPF network. So again, I'll just kind of separate these. So these are three different places around the world and we've connected them using OSPF. That was pretty much it for this video. Thanks for watching. If you liked it, press the like button. If you didn't like it, press the dislike button. If you have any questions, please let me know in the comments or don't let me know in the comments. If you but I will answer them if you do let me know. Yeah, that's pretty much it. Bye guys.